We're still continuing 7-7, right?
Yes, sir.
Now, got questions for you guys. All right, we're gonna start like this. What's 2 squared?
4.
4. Yeah, easy, right? Okay. Now, what do I have to do to 4? Maybe 4 is a bad example. To go back to 2.
Second.
Square root it. Good. Okay. Second. Square root. Second answer. Hit enter, and I get 2, right? Okay. 2 squared is 4. Square root of 4 is 2. All right. Same with 5. 5 squared is 25. Square root 25 is 5. Okay. Now, why does that work the way it does? I'm looking for one word. Rainy.
Oh, why? Just one word?
Door. No.
Inverse.
Inverses. They're inverses. A square root and a square power are inverse functions of one another. Okay, remember that? Whenever you take that to the algebra world and whenever you're doing it to the numbers, that means they undo one another. They cancel each other out. All right? You square a square root, they're both gone. You square root a square, they're both gone. Okay? Make sense? Okay. Next question. What is the natural log of 5?
25. 50.
Anybody know off the top of your head?
What?
Natural log of 5. 1.06609437912.
We were supposed to know that?
Sarcasm.
Oh my god. You just whip that out like all the time.
It's right here, yeah. It's whenever I need it. Now, I'm going to go and take E. Okay, watch what's about to happen. I'm going to do E, and I'm going to take E to that power. E to the power of 1.609437912. Enter, and it gives me 5.
So that's basically the square.
They're exactly. They're the exact same. They have the exact same relationship as square roots and square powers. They're inverses of one another, are e's and natural logs. They cancel each other out. Okay, Chamberlain.
So why do we have the E and LN if we got square and square root?
Because I was just making the comparison, right? We already know how to do square and square roots. Now we're going to do these with e's and natural logs.
But what's the difference between the two?
Okay. So they'll undo one another. And that's what this wonderful, beautiful pink slide talks about. Okay.
Right.
It is bright. It's bright for a reason. You know why it's bright? It's important. Get your attention, right? Focus on it. Okay. Now, if you look at the text up top, I just showed you that. All right. Years past, when I didn't have that beautiful calculator software, I just had to go with it, and I think that hurt this. I think that hurt this lesson. Okay. I just said, I'm just learn it and go with it. Now it makes sense. Okay. Because the natural base, which is E, and natural logs are inverse functions. Okay. They cancel each other out. What the other cool thing you can do with this, yes, I said cool, is that you can put them into a problem to cancel the other one out. So just like how in section 6 we took logs of both sides, you can take natural logs of both sides as well. Okay? The tricky one, you can do an E of both sides. You can. We will. Okay? You can take an E power of both sides. So the 2 examples here, e to the natural log of x, e to a natural log, inverse functions. Cancel each other out, you're left with just that x. Same thing over here. Natural log of e to the x, these 2 cancel each other out. You're left with just x. That's going to be the difference today. That's how you are going to get rid of a natural log or the e. So that way you can go through the rest of your problem and solve. Solve 4e to the negative 2x power minus 5 equals 3. These work a lot like your radical equations in the sense that you need to isolate your term first, okay? So first thing you notice, these problems don't mix up. You'll never have a problem like this where there's both e's and natural logs in it at the same time. Okay, that's not a thing. You'll have one or the other to start with. This one we're starting with e. Okay, everybody see that? So the first thing you need to do is do some algebra to isolate that e. So the first step in doing that would be what? Add 5. So we're going to add 5 to both sides. Gives you 4e to negative 2x equals 8. And next step to isolate the e would be what? Divide by 4. So it leaves you with e to negative 2x equals 2. Okay. Isolate it down to the e and whatever its exponent is. Okay? That's your first step. Whatever you have to do that, you do it. Sometimes it's an easy thing, sometimes it's easy, sometimes it's a little couple steps. Okay, it just depends. Alright, now that you have it isolated, you want to get rid of it by introducing its inverse. And e's inverse is what? Natural log. So just like last section, you can take a natural log of both sides. But the key is you have to do it to both sides, correct? Yeah. Okay, now, your next step, once you have it like this, okay? The reason I made that slide pink, okay, if you look, I can't go back right now since I have the text up on here, but if you look at that pink slide, it gives you two different things. It gives you e to the ln of x, and it gives you ln of e of x. Okay, now that x represents the exponent, but what it means is that whenever you have ln and e next to each other, they just cancel out. And you're left with just that exponent. Now, the long way of thinking about this, remember that a natural log is just a log with a base of e, right? So you can take your log property. You bring this negative 2x down in front. Okay?
What?
You bring your exponent down in front of a log, right? But when you do natural log of e to the first in your calculator, that ends up being 1. So it cancels, exactly. So you are left with negative 2x on the left equals the natural log of 2, because you had to introduce that natural log to both sides. Okay, Ron.
How did the LN
Last step, divide by negative 2.
we get negative 1.347. I mean 47.
So ln negative 2, or ln of 2 divided by negative 2 in your calculator. Make sure you close your parentheses on your natural log. Should give you negative point. Notice how we started the problem with e up top, right here, and we ended with a natural log in it. That'll always happen. Okay? If you start with e, what I give you, eventually you'll take a natural log, and vice versa when we get there.
So we'll start with that.
So right, okay. So whatever I start you off with, you'll finish the other way, because you have to introduce it to both sides. That way it cancels out. Make sense?
Mm-hmm.
Okay. Any questions? Okay. Next one. Here you go. That's all you.
And the E just disappeared.
Correct. Okay. Add 12.
Did you take extra homework?
I didn't know what I was going to sign yet.
Okay.
Divide by 3. Take a natural log. ln of e cancels, so 4x equals natural log of 9, which means x equals natural log of 9 over 4. And x is, what you guys have, 0.543, is that right?
0.549.
549. 3 is the next number.
Yeah.
Yeah. Okay, in your calculator. Make sure you close that parenthesis on that 9 there. All right. And sometimes, hey, and also make sure if that's ever a fraction, which it can be, make sure you do, parenthesis, make it be like 9/5. 9 divide 5, close parenthesis, divide by the 4 second. Okay, whatever you're taking the natural log of, if it happens to be a fraction, make sure you close it, all right? All right, let's change it up just a little bit. Okay, so solve 3 ln 4x equals 24. So now this one has a natural log in it. So eventually you're going to take an e. Okay?
We're going to divide this time.
Shh, I'll tell you. That's my job. I'll teach you. Okay. We're gonna get to it, okay? Because I'm gonna do a second problem here, okay? So write this one down. Just watch me. Watch me for a little bit, okay? I'm going to add in a problem that I'm gonna do because that's what I do with my life. I just work math. Let's make it 2 to the x plus 3 equals 4 to the 3x minus 7. Yeah, this is fun. What do I do?
Bases.
Make your bases the same. Okay, so 2 to the x plus 3. 4 is 2 squared. You distribute that 2. I go 2 to 6x minus 14. Set the exponents equal to one another. X plus 3 equals 6x minus 14. Add 14 gives me 17 equals 5x. So x equals 17/5. Yay, go me. All right, that's a typical Friday night. Okay, now, the reason I did that, I'll keep that over there in that beautiful green color. I'll show you in a second. Okay, so 3 natural log of 4x equals 24. What's your first step? Chamberlain?
Divide 4x over.
No. Nope. Divide 3. Get that natural log of 4x isolated first. So your first step is divide 3. I'm going to change colors here because I don't like that red. So ln of 4x equals 8. Okay? Now, this is the tricky step. Okay? In order, if you looked at that pink slide, okay, if you have them up, flip back to it. In order to cancel out the natural log, it had to be where?
In the front. In the exponent.
In the exponent. Natural log had to be in the exponent of e. Okay? Either look at that pink slide or look at your notes, right? That's what you wrote down. E to the ln of x equals x, right? So natural log, in order for us to cancel it, has to be in the exponent. So what I'm going to do is put it there, and I'm going to do e. That was a terrible e. Let's try that again. E to the ln of 4x equals e to the 8th.
So we can just put it in anytime, like put E in anytime.
Don't do it anytime. Okay? Shh, hang on, hold on. Don't do it whenever you want to. Okay? Do it when you have your natural log isolated. All right? Now, the reason why I did it over here, your bases are the same over here, so we brought the exponents down. I just took this guy and went backwards. I made 8 in the natural log of 4x. My exponents went the other way and introduced the base of e. Okay, see that? Okay, which is the weird part because your base is a letter. I get that, but remember that e is a number.
Right.
Okay, e is a number. Remember that. Okay, Chamberlain.
Can I start making my L's capital?
Sure. If that helps you, yeah. Okay. So now that you have this as e to the ln, they cancel, and 4x comes back down out of the exponents. That's the other weird part. Okay, that whatever you're left with, if you look at that pink slide, you're left 4x equals e to the 8th. That 4x comes back down. Okay. So the concepts here on this, the concepts whenever you start with a natural log are a little bit more complicated compared to when you start with an e. Okay. But it's the same kind of rules as we go. All right. Any questions on that stuff? Not quite. What's the last thing you got to do?
Plug it in.
Nope. Divide by 4. X equals e to the 8. Divide by 4. Now go to your calculator. E to the 8. Divide by 4. Make sure you get yourself out of that exponent when you hit e to the 8. Okay, you new calculator people. All right, especially because otherwise you'll do e to the 8 divided by 4 power, which will give you e to the 4th, or e to the 2nd, sorry. All right, you should have 745, 239. Right arrow.
Oh, I'm sure.
Yes.
Second. Where's the?
Thank you, Ron. Okay, 745.239. Natural log's isolated already, so you already take it to the e power. So e ln of the quantity x minus 8 to the 4th equals 4. Yes, I know it's asking. Yep. This e cancels this ln. Right? So the x minus 8 to the 4 comes back down. I missed my e to the 4th power, didn't I? Yeah, thank you. There we go. This e and ln cancel each other out, so the x minus 8 to the 4th comes back down. Okay. Now, if you're going to multiply this all the way out, you need to take 4x minus 8 binomials and FOIL them all the way through. Then you would have an x to the 4th, an x cubed, an x squared, an x, and a single constant term in a 5-term polynomial that you would then have to figure out how to solve. Ew. Or, how can you cancel out 2 4th powers? 4th root them. Chapter 6, you guys did so well in. 4th root, both sides. Those 4th powers cancel. You're left with x minus 8 equals e. Add 8. X equals e. E's power is what? 1 plus 8. E to the 1st plus 8. X equals 10.72 what? 718. Okay. The only type of word problem that we are going to do with e's is continuously compounded interest. All right, which adds a second formula you need to know. Yes, you can program this in your calculator. We're not going to take that time, but all you have to do is basically take the script I gave you in 7.2, take that program, change it, use the same prompts, use the same variables, and just change it to this one. Okay, because everything pretty much stays the same. P is still your principal, R is still your rate, T is still your time, A is still your ending amount. Those 4 things stay the same. Notice there's no what in this one? N. There's no N. There's no this type of account. It's not like it gets added. The interest gets added in so often. This interest gets added in continuously, hence continuously compounded interest. Okay, so your formula for this is A equals P times e to the RT power. A equals P times e to the RT power.
If we go to programs.
We're not. You can, but we're not.
Yeah, let's do the programs.
New. All right, here we go. Bless you. When Angie was born, her grandparents deposited $3,000 into a college savings account paying 4% interest compounded continuously. That's a key word, continuously, because that tells you the formula you use. Now, assuming no deposits or withdrawals, what will be the balance after 10 years? Okay. Yeah.
Can you explain continuously?
So, the formula you want to use for all three of these, since it says continuous, is A equals P times E to the RT power. Okay, so number one. Assuming no deposits or withdrawals, what will be the balance after 10 years? So we know that they started with 3,000. We don't know E. We know the rate's 4%, so we make that a decimal at 0.04. And we want to know the balance after 10 years. So do your simplify your exponent. So A equals 3,000 times E. 0.04 times 10 gives you 0.4. And then that goes into your calculator. 3,000 times E to the 0.4 power. Which should give you A to equal 4,475 and 47 cents. Okay, that's number one. No, that's a dollar sign. Oh, the one oh I see what you're saying. No, that's just me trying to. There. That's the parenthesis on the one and then a line above below the formula. I see what you're saying there. Okay. That's number one. All right, number two's question. How long will it take the balance to reach 10,000? Game changer. What are we looking for? T. You're looking for T now. Which means you know the N, you know P, you know R. You're looking for T. Alright, we couldn't do this type of question earlier because you didn't know how to do this. Now you do. So we want the ending amount to be $10,000, right? Okay, great. Your starting amount is still 3,000. Still to an E. And the rate of it is still 0.04, right? You're just trying to find T. So now you have an equation with E in it. So now you solve it the exact same way. First step, divide by 3,000. So 10,000 over 3,000 gives you, cut out 3 zeros, so what, 10 over 3? Nope. Equals E to the 0.04 T power. Now that you have your E isolated, you take a what? Natural log. Okay, so this is what I was talking about earlier. Natural log of 10/3. That's all inside the natural log's parentheses like that. Equals, natural log and E cancel out, so 0.04 T. Bring that exponent down. So now you divide by 0.04. So T equals the natural log of 10/3, all divided by 0.04. But whenever you plug this in, make sure whenever you divide, everybody's cool with this 10/3 being what you take the natural log of, right? Make sense? When you divide by the 0.04, you're dividing this whole side by 0.04. So the natural log of 10/3 divided by 0.04. So when you put that in your calculator, make sure you do 10 divide 3 after you hit that natural log, close parenthesis, then divide by 0.04. All right? Like I said, you're going to have to get better with the calculator and understand that it's the way it reads it. You should get about 30 years, like 30.09. Okay, so just round that off, about 30 years. Okay. That's number 2. Gosh, I'm almost out of room. How am I going to make 3 fit?
Erase one.
Make it smaller. You know what?
Erase one.
That's what she
What?
I just said with that.
I don't know where it went. Hold on. I didn't mean to make it gone.
How you gonna make it small?
Yes, I amused myself. Leave me alone. Let's make that.
I think, no, you can't. That's the bad part about it. You don't know how loud.
3. Shh, stop. All right, number 3 now. If her grandparents want Angie to have $10,000 after 18 years, how much would they need to invest? So now you're looking for what? No. You're looking for P. You want the end to be, the end game's 10 grand, right? Now we want to know the initial investment after 18 years. That was a wonderful 18. At the 0.04 interest rate. Okay. So here's how I would take this problem. I would do 18 times 0.04 first. Which is 0.72. Okay. Now, e to the 0.72 power is a, starts with an n. It's a number. You're attached to a variable. So all you need to do is, nope, divide by that number. So do 10,000 divided by e to the 0.72 power, which should give you 4,867.52. That's what it is. See how you get rid of, cancel these out? So that's P. P equals that. Sure.
What was it again?
505. Shh, quiet. 505, 9 through 18. All right. Oh, I need to unfreeze the screen for you guys. There you go. Okay, page 505, 30th. 9 through 18. That's your sign for this one, okay?